No, bad things are happening. Don't edit your slides at the last minute.
Okay, man needs no introduction. No, he doesn't need this. Joseph for me actually just moved to Lakewood recently, right?
Yes, sometime.
And look at that, and he's brave enough to like right away come give a talk. So that should be an inspiration to all of you
To give talks.
come forth and give a talk on whatever topic. Just hit me or Steve or Morty up on Slack, and we'll talk. We'll shoot about it. And yeah, thank you everyone for coming. And take it away.
Hello, everyone. So tonight we're going to talk about AI, which is an exciting topic for everyone. We're all interested in it, but we need to define what it means so that we can be interested in what so we can know what we're interested in. Now, the term AI is used very loosely, and it's used in different ways by different people. In fact, I'm going to give two definitions of it tonight, one contradicting the other. It'll still make sense, but you'll see that it can be used in whatever way you want, and it can mean anything. So the three terms that we use are AI, machine learning, and deep learning. Now, machine learning and deep learning are well-defined terms because they mean a specific technique, but AI can mean anything. The truth is AI is usually explained as, slides out of order? Okay, we'll do this one first. AI is usually explained as the entire field of intelligent, even programs, things that existed a long time ago before there was anything like deep learning or machine learning, before we had the compute power for it, before we had the data for it. Things like computers playing chess, that's been around for since before me, and other things like that. So the field we call AI, or artificial intelligence. Machine learning is a specific technique, which we're going to discuss, and deep learning is a specific subset of machine learning. So like that picture, I'm not going to flip back and forth because you guys are going to go nuts. Machine learning is a technique. Now, what is the technique of machine learning? Machine learning is what it sounds like. The machine learns. That is, it's not a program where you define certain steps, do this, then do that, then do the thing after. This is the data. These are the matches between inputs and outputs. You figure it out. You figure out how you get from input to output, and then when we give you a new input, later we want you to give us the correct output. That's something we will hopefully do tonight in a very clear way. And then deep learning is an even newer technique, which was, I believe, first conceived in the 50s, 1950s, not 2050s. And some stuff was thought of in the 1800s, that's the truth. But they thought of the concepts, but there was no practical way to use it because they thought of what they called a neural network. They called them perceptrons. They couldn't do anything with them because you need intense compute power, which we now have, and you need large amounts of data to do anything effectively. So, what's on the next slide? Oh, look at that. That's so cute. Okay. So what can you do with AI today, whether you know more than I just explained or with what I just explained or even not understanding what I just explained? The left side of the room didn't understand it all. There's three things you can do. Well, no, there's three things to do, one of which you can do right away. You can use machine learning APIs. Now, we use APIs all the time as programmers, but for some reason people don't think of machine learning in their solutions when they solve problems because it's not something they necessarily understand. But you don't have to understand it in order to use the APIs. You kind of have to know what it does. You kind of have to know where to find them, but that's about it. You can use them and start solving problems with them, creating programs with them, coming up with unique programs with them right away without knowing anything more. With a little bit more effort, you can learn how to take pre-trained and pre-packaged models and incorporate them in your programs. That means you don't have to know how to do machine learning. You just have to know how to take the models that are produced by machine learning and deep learning, the neural networks, and the trained neural networks, and put them into your software. Not something that's beyond reach, even just as a programmer. You don't need to know math for it. You don't need to know calculus. You just need to know a few new things, and that's something you can pick up very quickly. And the third one is learning how to create your own models, which is something that takes time to learn how to do. It can take a year, it can take a month, depending on the person. But you don't need to know any calculus, really. Just a little bit. They say you need to know calculus, but I really don't, so you don't. You need to understand, to some extent, how it works. The more you understand how it works, the easier time you'll have figuring things out and debugging things. But there's really a large range of understanding that people have. Some people come from math backgrounds and they really understand the math. They happen to not make good programmers, but sorry. Then there are some people that come from physics backgrounds, some people that come from computer programming backgrounds, and they know some of the math, and that's fine. Anyone can do it with whatever background they come from. You don't really have to know the calculus behind it to understand what you're doing. So, I'm sorry? Okay, so that's one reason that people don't touch machine learning. It's like, well, my company is a small company. It doesn't have enough data. I can't do anything with it. So the type of APIs that are out there, the most common ones are image-based neural networks or document understanding. Those are already built. Those are already trained. They're packaged in APIs. You don't have to do it. You don't have to have any data for it to enhance what you're doing. And many of us assume that it's not relevant to us, but the truth is, if you understand what the power behind it is, you might think of solutions differently, or different solutions. Okay, so we're going off the slides, and we're going to do what you should never ever do, which is do some demos. Okay, so okay, so the screen is tiny. Let's get rid of this. Press F11. There is a full screen somewhere. Window. I'm going to be switching out of it, so it's fine. Okay, so this is an example of using an API in an app. It's not a real app, and it's not a real API. I mean, it's a real API. Most companies have similar APIs. Most of the big companies have similar APIs. I happen to primarily use Google for everything, so that's where I look first. But IBM, under the brand Watson, has some interesting APIs. And the truth is, the one I wanted to use tonight, which they've slowly sunsetted, could actually tell your personality from a couple of paragraphs of text. So we could scrape it off someone's Facebook or Twitter, and we can know their personality. Obviously, they weren't comfortable with that, so they kind of sunsetted it. Sorry, can't show that to you. It was really interesting. I used to show it all the time. But instead, I'm going to do something similar, which is a tone analyzer. And you're starting to see things similar to this incorporated in many modern apps, where they look at what you're saying and they sort of suggest, hey, maybe this is not the tone you want to be using. You will be seeing it more and more. They won't be using IBM's API. They'll be using their own. But you can have that same power that these large companies have by analyzing their own data and building their own models and creating this. You can have that prepackaged in an API, and you can do the same thing in your small app at little to no cost. And let's have a look at what it does. Okay, so I made a small chat window, which will analyze the tone of the messages. I'm playing both sides of the conversation. It'll probably tell you more about me than the API. I noticed a pattern as I was testing it out. I was trying to get angry. I was trying to, and then no matter what I did, it said analytical. It said other things also, and it's like, okay, I guess that's the way I speak. It doesn't work for every what they call utterance. There's sometimes you'll put a sentence in and it just doesn't get a tone off it. That is why I have the console open, so I can see that it's working and it just didn't get any tone back. All right, let's start. All right, good evening. we're pretending we're a customer service representative. How may I help? Hey, that wasn't even one of my planned jokes, and I got a laugh. How may I help you? I'm talking about the analytical thing, not this. This wasn't funny. Okay, so let's see what comes back with this. Joy and tentative. Ooh, not analytical, but tentative. Oh, I get that a lot too. 90%, so it's a stronger match for tentative. Now, as a UI, this is not very good. Although some of the programmers are like, why not? This is perfect. That's what I thought. But it kind of displays the information we need for this demonstration. You could do so many things. You could have colorful graphs on the side, many things I thought of, but in no way could make myself. So we'll put that message up there. If I make it a little wider, you can even see how it goes to the right and to the left every other time. Amazing feature. All right, how may I help you? I am having trouble. Whoa, that was not smart. Using your product. It sucks. And for that we get nothing, probably because they think sucks is a bad word. Yeah. Analytical. It does. It blocked it. It did. That's why it didn't come up with anything, I think. I just figured that out now. I really couldn't figure it out. So, analytical. I'm having trouble using your product. It is your fault. Can we get angry, maybe? If we're lucky. We'll try. No, still analytical. That's going to be a theme tonight. Is your fault. I'm sorry to hear that. You you must be having a bad night. Now, this is the kind of conversation you do want your customer service representatives. Fear and confidence. Interesting. Okay, so that's a very good question. So this science is not very, it's not so much the machine learning as the science of, I guess, tone. I guess you could blame it on the machine learning a little. I'm not going to. But let's say the personality one, I did it with many people, and as example with many people, and they were just like very quiet after they read their personality. It was pretty good. I think this is based off that. I'm sorry to hear you must be having that. You must be having a bad night. Fear, maybe. Confidence, 50%. Both of these are not strong signals. So it tells you how confident it is in its thing. That number. If it went to 1, that would be... No, it's a 57% match to fear. And a 54... Oh, yeah, exactly. And you can actually put a whole chat in and send it to API as well. And someone's behind me. What's going on? Sure. Okay. You could actually slip this, and you can assess your customer service agents, see the conversations as a whole, how they're turning out. You have certain representatives, the conversation just seems to be going sideways. That's a problem. You have, or you can help them out by putting something like this on their screen, so before they send the message, they're like, hey, okay, I see what tone I'm expressing. Let me do something different. So that's one way an API like this could be used. Do you want to do more, or should we move on to the next thing? How much time do we have?
Are you going to show us the code behind this?
Should I show you the code behind this? Okay, so this is an Angular, yes, it's not React. It's a small Angular app that does this, and it makes an API call on change for the input window. Let's see if we can have a look at this. How many people here use React over Angular? How many people here use Angular over React? I assume that the Angular people are just humble and shy, that's all. Okay, so I don't know if there's much joy in seeing the Angular code.
Is there a library that will feed in, like you put in your languages and it tells you about you, your personality?
That you put in your language?
Languages and technologies you use in it.
We could make something like that. I mean, I can tell you right now without it. If you use React, then you're... No, I'm kidding.
Just show where it calls
Yes, I will show where it calls the API. Messages.service. Now, the truth is this, I had to make, as you're supposed to, you're not supposed to call it from the front end because you have API keys there. So I made a back end. So here's where it calls the back end, localhost 5000, which is running a Flask app in, no, this is not what I meant to show you. Where is it running? I just turned it on before, not that I'm going to remember where it is. I believe it's a Flask app running on my computer, but if not, then who knows? I'm still new to Mac, and sometimes I can't get to another window. Let's see. Talk would be a good one to look for. Yes, very good. Okay, so this simple Flask API is sending it. It uses there. I don't care if you see the API key because it's limited to free. So even if you could steal that API key, you wouldn't be able to do anything that cost me any money. So here's the API key. Here's the service. This is their library. It's a Node.js library. They have it in every language. They have an SDK for every language. Not every language, literally, COBOL programmers, but for most common languages. Set service URL, and then in the route, it does tone analyzer.tone. It calls tone with the text, gets result, and it returns it to that call on the front end for Angular. A long time ago on an old computer, I had a key sequence to press to go into presentation mode. That might make it a little better and easier to see. Okay, so this is basically, this is their library, and this is their library as well. And there you go.
Did they send you anything back besides the actual tone? Like why we didn't give you a tone or something like that?
I don't think so. I do know that they separate it into sentences. I just took the document tone for the demonstration. They do separate it into sentences, and they give you the tone of each sentence, and then they give you the overall tone of the whole document, they call it. Yes. Okay, let's switch to our next demonstration. This one I did not make, mostly, let's let this thing turn on, mostly because the machine learning model puts out the coordinates of these dots, and if I step back, it'll be lines. I should have tested this beforehand. Okay, so get my arms. Can you get my arms? Yes, you got my arm. Arm, elbow. It mostly shows the points of the shoulders, the elbows, the eyes, and ears, and nose. And this is utterly useless, but pretty interesting. Now, so this is made with a prepackaged model. This can run on a cell phone. Oh, it's for multi-pose. Let's just single pose. This can run on a cell phone. It's light enough to do that. You can put it in an iOS app, in an Android app, in a hybrid app, native script or Ionic or whatever it is used, React Native, I'm sorry. And it's running on the device. What this does is it points out a few parts of the body, and you can do things with different poses. So people use this in like exercise apps, until you do the pose. You can put it in games and control the game that way. Mostly this was done for research purposes more than for anything else. But some projects use it actually. I don't know if Tesla uses something like this, but the Comma AI project, which is like a self-driving open source thing, uses something similar to this to see if you're looking at the road or not. If you're not looking at the road, it warns you, and then it either turns off, which is a bad idea. If you're not looking at the road, it should continue driving. That's what I would say. But
Face ID on iOS devices also uses deep learning. I think they announced that once at their thing, so it's probably similar to
something similar to this, yeah.
application.
Yeah, I would agree.
Also, you use this if you just want to know if there's a person in the picture.
Yes, but you could use something much simpler than this also.
Yeah, there's one that is like somebody's arm in the picture
Right.
for, let's say, filtering, which is something that
Oh,
did, and you
yeah.
got this exact product.
Interesting. That's really cool. I never thought of that. So yes, this is an example of the second thing that I put on the list. This is a little harder to learn how to do, harder than doing today. You could do it tomorrow. The package model is just a file with some weights and the structure of the neural network. You don't have to know what that means, and you can look up tutorials how to how to put these models in your app. There's SDKs for them. It's not intrinsically a skill in machine learning to be able to use this, even though it looks cool. It's like people in machine learning make these demonstrations, and it's like, wow, this guy's an expert at what? Nothing. Programming. Nothing to do with machine learning. So you can do that too, and you can make amazing things in your apps. We end at 9? Oh, good. We're going to go back to the chat soon. Okay. Now, most fun of all, I think, let me make sure it's running. It is a Python project. Somebody asked me about Python. Somebody asked me about languages for machine learning. Go. Who has that question in their mind? No one? No? Yes. They had the question. What languages? So for the most part, when you train the models, you're using Python. Meaning, when you build the machine learning models, when you gather the data, when you process the data, you don't have to be using Python, but mostly you would use Python or other data pipeline that the business intelligence people will tell you about. Why? Because it has the most support. The libraries like TensorFlow and another one from Facebook, which I won't name. You know, the people who make React. PyTorch, yes. Are mostly in Python. Now TensorFlow has TensorFlow.js, which is what's used for that PoseNet model, which can take a model that's created in Python. The model is language neutral, and it can run it in a JS, in a regular web app. So you can really put it anywhere. There's also TensorFlow Lite and TensorFlow Mini, Micro, something like that for really small devices. And PyTorch doesn't have anything like that. No, really, they don't. What is TensorFlow? So TensorFlow is the premier. See, unlike Angular and React, where Facebook won, TensorFlow is way more popular than PyTorch, although PyTorch is gaining. So it's at 10%, which it got really quickly. I'm joking. It's probably way worse now, like 30 or 40%. Worse, yes. He said worse, that it got more popular. It's growing and getting more popular, but TensorFlow is definitely still the lead in production and in popularity. What does it do? So it's a library that does the math for machine learning. So, okay, let's talk more about machine learning and why we needed compute power to do it, and especially deep learning. So you need compute power, but not nearly as much. So these algorithms that they came up with in the 50s, where they said, hey, we can mimic this part of the human brain or part of how the human brain works and do it mathematically, requires a lot of math to be done, and for it to be done over and over and over again. And even if you're not using large amounts of data, which for some things you're not, you're still doing the math over and over and over again. Today we have that compute power. Mostly people like to give credit to gamers for wanting faster and faster GPUs. That's true to some extent, but you can do machine learning without a GPU nowadays because the CPUs are strong enough. So do we still have to thank the gamers? I'm not sure. And there's a the Bitcoin miners. They're stealing the GPUs from the machine learning people. Yeah, it's the new GPUs come out and you can't get them to do machine learning. Thank you. I'm not going to do that. I'll wait till the next one comes out and get the old one, because what can I do? But even without that, there's such a demand for mining that there's just not enough for machine learning. Yeah. So they have these on certain models, but not on all of them. They like selling them. I'm sorry? Right, but they also block some machine learning on certain models also for no reason. Well, I have way too much time and not enough slides. Sorry. Aha. Okay. The source code for that camera thing is not mine. You can find it on GitHub. Let's find it on GitHub, because let's be honest, I didn't write it. TFJS, GitHub. Okay, so if you're going to be implementing models, this is one of the places to go. This is part of the TensorFlow repository. PyTorch doesn't have something like this. And I can't win the React fight, but I can win this one. Where was it? Models? I don't see it. Am I in models already? Oh, I'm not in the right place. Haha. Okay, and they call this one PoseNet. Okay, and this is the demo. What would you like to see?
What does it take to use it to do something with it?
All right, let's have a look. Okay, it imports from PoseNet and from TensorFlow. And this is all aesthetics. Let's see. Toggle loading UI, nothing important yet. So tuple, draw point, those are nice. Draw segment, also important. Draw skeleton, very important. Key points, but where's the machine learning? Where does the picture, this is all rendering it. We want to see where the, I'm almost at the bottom, so it's either here or it's not. No, it's not in this file. What is this file called? Demo util. So let's look at, it's not Coco. Let's see what else is called. I guess so. I wouldn't put it there, but it's 486 lines. Let's scroll slowly. Okay, set up camera. Load video. We're getting warmer. Okay. GUI state algorithm multi-pose. Set up GUI. We're not there yet. Add folder. Not quite there. Thank you for the question, by the way. I know him, don't worry. Update GUI. That open single, blah, blah, blah. There was a GUI on the side that had like choices. I think that's what it's referring to. Algorithm controller. Okay, single is one. Okay, single is going to be the name of the model. I think. We just want to see where it imports it really. Yeah, it did import it in the other file. We should really be there. Okay. Single dot open, single pose. It's not here. So yeah, most of this project is how to display it so nicely. Let's go back to demoutil.js. As PoseNet. Let's look for PoseNet. PoseNet. That's for drawing the skeleton. Bounding box, key points. So I guess actually this is it. The different calls to PoseNet. Like here it gets a bounding box, which we don't use at all in this demonstration. But we do get key points. Let me go up one.
Oh, is it passing in the video into the
Did you see that?
I don't know, but it has to be passing something in order to get something else. So what's it passing?
Okay, this is drawing heat maps, showing single pose get offset points. Heat map values. I mean, this is using the model. It's passing in.
It doesn't pass in the image directly. It like takes the image
And processes it first, you're saying. Okay?
and represents it as like a matrix or something. And then
Yeah. Probably. Okay. Thank you for your help. Next time ask me that question in the afternoon. Thank you very much.
Sort of disappointing. You don't really. It's all just about using the SDK and using.
Right. It's
Not really understanding.
that's a good point. It's not about the machine learning, it's about using the SDK. It's about being a programmer, not so much a machine learning engineer. Where was I? Okay, A43, we're doing good. Okay, so the third one is a model that I took from the TensorFlow models in Python. TensorFlow models, they've since moved it because it's based on TensorFlow 1, not TensorFlow 2. Much like Angular 1, TensorFlow 1 was very difficult to use, but there was nothing else, so everyone used it. But it was really difficult to use. TensorFlow 2 is very easy to use, much like Angular 2+. but it's too late for some reason. Tonight on Comparing JavaScript Frameworks. What, Angular? Should have changed the name. It's not a bad idea. No, but TensorFlow, even though it was hard to use it, they came out with 2 quick enough before PyTorch took off, as opposed to Angular, where they didn't. They took a long time to get out there. Okay, so it's not here anymore, but basically it's a model that they put out. So when they put out a model, they put out the code for the model. They don't necessarily put out the data, but the data set was available somewhere else, and they don't have it trained. That means you need a tremendous amount of compute power, which incidentally you can buy from them, in order to train the model. And I don't think that's why they're putting the models out. In order to train the model to make it do something useful. Fortunately, someone on the internet, I don't know who he was, in the comments on GitHub, he had trained it himself and offered to share the trained version of the model with the world. So that was good for us. He had 8 GPUs. I don't know why, but he did. And he trained it and gave us the checkpoints, they're called, the weights, which we'll get into soon if we have the time. It can take days and weeks. With GPU, it could still take weeks with 8 GPUs, but I don't think this was such a big model. That's a long time. These big ones that they put out nowadays do. It has like 1 billion parameters, and they're training for who knows how long. Okay, so what this one does is it takes an image, and it adds a caption to the image. So since you guys are not on camera, if any of you have an image of something, a mountain, a river, a giraffe. I tend to have giraffes, and machine learning models like giraffes. I don't know why. They're like horses with long necks. For some reason, they can identify them, or they just think trees are giraffes. I'm not sure. But they often find giraffes, you'll find, for some reason. And that's another thing about machine learning. You don't really have to know how it works. Even when you're doing machine learning, you kind of know what works. So for a lot of the image recognition, even the experts, one of the techniques they use are called convolutional neural networks. And one of the experts, whose name I can't recall right now because I don't remember which one it was just like, this shouldn't work, but it does. I don't know why it works, but it does. Someone tried it, it works, and we all do it. Okay, so what this model does is it's hooked up to a Twitter account, which if you tag with an image in a tweet, it will put a caption on it. I happen to have some images of giraffes on my computer. I don't know why, just for testing this. And if you tag at caption _image, this used to be in the cloud and used to work all the time. I didn't check on it in a long time. After 3 years, something changed, so I just have it running on my computer. I didn't upload it anywhere, so it'll only work while my computer's on and the script is running. But I will tweet that random picture, and it will reply. These are all old ones. Have I done this before? Yes, I've done this before. This is the tweet. Let's see. Let's wait a minute. That's not what Control R should do. Hopefully this works. This is the wrong one. I know I have more Python windows open.
Use 3 fingers and swipe up.
Up?
Yeah.
Okay. Python. WebStorm. Compiled successfully. This is the wrong one. Ingest. There we are. Okay, run. App is running. Sorry, it's not here. Okay. That is the image, and I hope it replied to it because it looks like it did. It looks like it read it. It's just much cooler if there's the tweet reply and you can actually see that it's working. Then I will ask one of you to do a picture so you know I'm not making this up. However, mine is not working. What? It shows you some analytics. Total engagement 0. Which hopefully there will be 0. Okay, so as you can see down here, it took that image and it said a giraffe standing in a field in tall grass. I'm going to restart this just in case that was old. Come on. Okay. I'm going to reply to this tweet with a different giraffe and at caption image. I don't know which one I used last time. Oh, I do. Dwarf giraffe I did not use last time. Tweet. Come on. Let's see. We watch, we wait. Okay. It definitely is reading it. Still a giraffe standing in a tall field of grass, but why isn't it replying? We're not going to debug that now.
Is that the first one or the second one?
That's the second one. There we go. A giraffe standing in a field of tall grass. Does anyone have... You're not on camera. Does anyone have a Twitter account? You know, for development purposes. A zebra.
I'm kidding. It was a joke. It was an inside joke.
Oh. Okay. I'd love it if someone could do that. It's at caption image, caption_image, but you don't have to if you don't feel comfortable with it. Somebody's doing it.
Oh, I need to find an image. Hold up.
It'll be in notifications. Let's close this. So we have the regular. Yes, I tested it a lot.
What's it called? At image.
At caption_image.
All lowercase.
All lowercase.
It's Twitter, actually. It's not case sensitive.
It's not.
I don't think it is. How would you know that? The ads get worse when you start blocking them. They get random. What?
That was actually me.
Oh, that was you?
Yeah.
Oh, I'm sorry. How do I unblock you? Sorry. It actually won't work well on something like that, like a close-up shot of something, because they wasn't trained on that. It was trained on like more pulled-back landscape shots. I'm sorry. I'll unblock you. I don't know how to unblock you. Okay, I'll search for you. What is your... It looked weird. I thought it was an ad. Okay, we'll do it after. Someone else. Okay, this. And it has a reply already. These are guns. What does it say? Close-up picture. Yeah, it really... It doesn't say the word guns. So yeah, it doesn't work very well on close-up things, but it does work on like the type of images you'll find in a search engine. And that's really cheating when we do that. If I like search for zebras and then use that picture and then run it through the neural network, it'll say, you know, zebra standing in a field because... You want us? Okay. Okay, let's see. Zebra. Here's the thing. I think it's cheating because it's the same or different neural network picking out this image in the first place. But I will save image as... That's actually not a really large one, but it's in downloads. Let's do it. Caption image. Cool. A zebra standing in a field of grass. Yeah, that's not going to work. Oh, maybe. Let's see. A close-up of Gary's text. Let's see what we got. No. A clock on a building with a sky background. Okay, there's no clock. But there's a building with a sky background, so...
Where does it think the clock is? Hold on.
I don't think it knows what a clock is. You could... Yeah, standing the light.
It's like a light, yeah, it's like a nerd comment infinity.
So the way these are trained is a bunch of images with captions. And there's enough buildings that look like this that have clocks. So they had the word clock in the caption, so it threw it in there. Overfitting, yeah. overfitting. It's overfitting to the. Yeah, that would be overfitting. It's overfitting to the training data. Yeah.
So are you going to show us the APIs on how this is called?
No. Because I don't. I mean, I do have the code. So this, fine. I'll show you the Python code. Here we go. This calls an API, my API, on a machine learning engine platform, right here. It makes a call to this model on Google Cloud Platform, which is my model that I uploaded there. It's the 25th version of the model, so it's like done 1, done 2, done 25. So yeah, it took some time to do. I'm not nearly done with that project, and recently I've decided maybe to go back to that project and add in some more things to it. So we'll see what happens.
What does it mean to, what do you mean to you iterate on the model? What do you do when you iterate from one to another?
Oh, I meant, like when you save a document.
Yeah, what changes?
So what changes did I make? This is 3 years ago. What was I doing? Oh, okay. So the way this model works is it only predicts the next word in the sentence. You give it a part of a sentence or nothing, and it predicts what the next word is. So there's a loop there. In the model that Google released, the loop was in Python. So the model only gave one word. The TensorFlow model only gave one word, and each time it hit it for another word. I didn't want to deploy an API that needs to be hit that many times. Plus, I don't know why, I wanted it all to be in a TensorFlow model. So I was figuring out how to make a loop in TensorFlow 1, which anyone who used TensorFlow 1 is probably groaning now because it was not fun. TensorFlow 2 is fine. But TensorFlow 1, it was a painful experience to do. So that's what happened there. One other thing that I wanted to show is something called the TensorFlow Playground, playground.tensorflow.org. And I want to use this to explain. So let's reset. Okay. Machine learning in its simplest form is finding a function that explains a graph. Meaning, with a graph like this, or I hope I could make a simpler one, but I can't. Let me see if I can make that show better. Okay. You got your blue dots and your orange dots. Okay. Now, there's two axes here. So there's a relationship between, for any dot that there is, it's either a blue one or an orange one. In different terms, if you had a chart of heights and weights, you could say that people who are 6 feet are more likely to be 200 pounds. I don't know if I'm in the best shape to make that rule. I'm not 6 feet. I'm not 200 pounds, but I'm not 6 feet. But anyway, if you charted people's heights and weights, it would sort of make a diagonal line. Okay? In this case, the samples they're giving are orange dots and blue dots. And what you'd want your machine learning, and this, even though this is proposing to show neural networks, this is actually when you use only one neuron, that's the same as machine learning, which I'll explain in a minute if we have time, which we don't. So this, using one neuron, can actually learn the background is predictions. So there's orange dots, and the output of the machine learning network is the orange background and the blue background. So it sort of knows where the orange dots should be and where the blue dots should be. Now, this is relatively simple. You can have more complicated data, something that looks like this, where you don't have a simple line, and you'll have to start using more complex inputs, and your neural network will have to grow. A little bit. And don't worry, I did it successfully in the other tab. Say again?
How do you know how many neurons are placed in each layer?
You don't. It's an art, not a science.
What's the benefit of having multiple layers?
Multiple layers work better than the width of the layer. And it's struggling, but it's starting. You're basically starting to see orange behind the orange dots. There we go. Let's pause it because that's before it goes away. Okay. With this tool, which we can't fully appreciate now, as you're learning neural networks and you understand the terms such as weights and what each neuron is, this can really help you understand what's happening inside. But as just an overview, what I wanted to show was, on the simplest level, one neuron, which is machine learning, can understand basic data. It can make a line on a graph. It can do other things too, but it can make a line on a graph. Whereas you have something complicated like an image, is there a cat in this image or not? That's something that really boggles the mind that a computer can do. That you can program something that can understand whether it's a cat or a dog. Or you can get more specific, what breed of dog. And it just works. With multiple layers, with a large enough neural network, and the data structured the right way, you can do almost anything so far. There's really very few problems they've thrown at it. They've used it for cancer detection in X-ray images. They've used it for finding weapons. The TSA actually did a contest of they gave out the images that happen in those scanners. Those, where you hold your hand up and you go through. I don't know, I haven't flown recently. And the contest was to create a neural network that can find suspicious things under clothing. Boggles the mind.
Does that require someone to go and like mark the data and say you don't have one?
Yeah, they gave out marked data of a 3D scan. Yeah, they did. Like,
Hard part, like, I mean, this doesn't seem, I don't know anything about it. It doesn't seem like a complicated part. You'd imagine these are those algorithms that exist already, and you put the data in and the model comes out. Is that correct?
they don't exist. They didn't exist.
Okay, now it is.
I mean, now it exists. Someone won the contest.
There's a version of it. No, okay, why so why do you want specifically for
Because it.
layers and stuff?
So when you're doing machine learning, there's a temptation to do what I just did now, which was if you throw enough layers and enough neurons on it, it'll work. But the truth is, it just doesn't work. Sometimes you just try it and it doesn't work. You can. So some of it is guesswork, but it's educated guesses. The more you do it, the more you understand why something might not have worked and what you should tweak. But they're still guesses. They're educated guesses, but they're, at the end of the day, there's some aspect of guessing. And one more 30-second thing, if I may indulge. So this I saw in a course once. I saw something similar in a course. I came up with this example. But if these numbers, these two arrays of numbers they match up. The first element, and this is something that drove me nuts as a programmer. Wouldn't you put the matches together? But no, they're matched by index. That's how data scientists do things. So 1 gallon is 3.7 liters, 2 gallons is 7.5, 3 gallons is 11.56, et cetera, et cetera. Now, in order to be impressive and type it, I just hit it down there, don't worry. This is defining the model in TensorFlow 2, which is that simple. And basically, this creates one neuron, like we had on the screen before. This is telling it to run it through 700 times so that it can learn. And
then you're going to predict number 10.
and then it's going to predict how many liters is 10 gallons. Now, we can look at this and say it's exactly 30.78, because we can just do the math. I'm sorry, what did I say? Yeah, 10 gallons. It's exactly this. So, but it's never going to be exact because it's not actual math. So after 700 times, we're almost done. And there's no there is a GPU in here, I think. It might have been. Why not? The default TensorFlow package uses the GPU nowadays.
Either way, your mouse is blocking the prediction.
Yes, we're going to focus because we don't have extra time now. Okay, 37.78, which is actually bang on. Oh, so it's an estimate. Point is, it's not doing actual math. It modeled the data. It figured out something close. It'll never get it exact. Thank you. I think the coolest one was the colorful one, but I didn't use that correctly. This is nice. It actually, the loss, it can measure the difference. This is not a score of confidence. It can measure the difference between what it does is each step, I should have just explained this. Each step of the way, it makes a prediction. Here's my model, random weights. Here's my prediction. It's off. Let me adjust a little in the right direction. Then it does it again. It's like, ooh, I'm off by a little less. Let me adjust a little more. It does it again. I'm off by a little. Let me adjust a little more. And it does it again and again and again and again until the model is somewhat accurate. Any other questions?
That explanation is for a neuron or in that network, or that's an explanation for the model?
For the whole network.
The whole network.
For all the neurons.
How do neurons work? How do they...
Each, this is where the calculus comes in, so I can only explain it as someone who doesn't understand the calculus. So it knows how to adjust. It knows which direction to adjust because of gradients, and it knows which neurons to apply it to through something called backpropagation. Ooh, sorry, can't explain it now offhand just because I don't understand it well enough. But basically, it knows which you know which neuron needs to be adjusted which way, and then you have something called the learning rate, which is set to a fraction of 1. So you only adjust a little bit at a time because you don't want to get it wrong. You don't want to overshoot. You're just adjusting a little, and you can run it again and again and again. Those are the vocabulary words.
The learning rate is a parameter that you can choose.
That you can control. Right.
So it's like how much you move towards.
Yes. And you just move a little bit at a time because you don't want to overshoot. You don't want to take too much stock in each time it's run through. You want it on the aggregate. So you learn very little in each step.
You said that a check it goes back and forth. Like, am I right or that's a GAN?
No, GAN is something different where you actually have 2 neural networks where they do one, let's say a GAN that generates images of cats would be made up of a neural network that can predict images of cats. Is this a cat, yes or no? And another neural network which works backwards and generates images. And basically the cat neural network says that's not a cat. And the other neural network changes the pixels. And then it says that's still not a cat, but you're a little closer until it can start making cats. And they have that with faces and... Yeah. Yeah. That's called generative adversarial networks, GANs. I think it's based on that. Something. Yeah. Any other questions? Thank you very much.